Hi, my name is Kat, and this is my Affine Transformations and Matrices assignment. So I actually kind of did a whole bunch of this because I was enjoying the task work, and I may have oversized a lot of the API for it. Where is my API? So this is the core of my API. It's a bunch of classes, one for representing singular points, and one for representing actual point objects. Um, with their own little composers for setting affine transformations. My custom vector 2D and vector 3D classes. I went a bit ham with explicit operators just to make my life a little bit more convenient. Kind of fleshed it out just for a bit of fun. The core of the actual matrix operations is here. And so basically this is just a bunch of static functions that create a matrix with the correct positional elements set to perform said matrices. And I've actually done it also for like both the shear and the reflection matrices. I also took it a step further and find a whole bunch of operators for this particular matrix class because it was just easier than handling a lot of function calls. I also defined the matrix 4x4 class because I figured may as well. It's good to get practice writing that kind of stuff. As you can see, I kind of wrote a bunch of nested. Well, this one here is a bit more nested. Nested class that calculates the row column multiplications, and then that is just called over and over again to actually perform the rest of the multiplications required for matrix multiplication. And up here is just a short form vector for demultiplication. Initially, when I saw the comment of implement a camera, I assumed a projection matrix. So I actually fully implemented a 4x4 matrix projection matrix, which was pretty interesting. Definitely an overstep compared to what the actual requirement for implementing a camera was, but here you go. You can see that I'm calling the get off the graphic projection wherever I've defined that. There we go. So that, defined the whole orthographic projection and pretty much defined a camera frustum, which was definitely a bit of an overstep. And then I also went back through and defined the camera in the way that was taught during the unit itself. So here you've got your translation, your scale, and your rotation matrix, and that's like the translation matrix of the camera, or I guess you could say the world matrix, right? And so rather than handling that multiplication within the camera class, it's actually handled within, I think it's the matrix multiplication somewhere here. Oh no, it's not. Where did I put it? I put it somewhere. We'll find in a minute. So this is just a generic component that I wrote for scaling. I've got one for scaling, I've got one for translation. I also have this class because the way that I defined a lot of the objects was using effectively a list and then just calculating the points themselves as a list. So I could just do for each, calculate that, do transform. And so I think that actually, looking at this, that world matrix or the world matrix is multiplied actually within the point class, which is the class used to there we go, which is used to define translations on a point within an object. So as you can see here, we've got the translation component coming in, the rotation component coming in, and the scale component coming in, and we generate our model matrix here using those nice inbuilt static functions, making my life easy. And then if there is a camera instance, we do the world matrix setting, and we multiply that initial model matrix by it and set that. Otherwise, we just ignore the setting of the world matrix because maybe it's just not present in the scene at that point. You don't want everything to break, so it's a nice thing to do. Is there any other stuff in this code that I really need to talk about? Oh, the way that I handled setting the line renderers between the objects was this vertex pair class. So basically, it just defines an object that it starts the line cast at, and then has a reference to the object that it ends at, so that I could just define shapes by interlinking object references effectively. And it does that pretty well. I didn't want to spend a whole bunch of time on that if I didn't have to, effectively. So that's pretty much what that does. Other than that, the only other real major thing to note is that I did set up a whole bunch of unit tests, just to make sure that all the functionality was behaving as expected. As you can see, somewhat extensive. I'd rather know that things are working than not. We go through setting some different properties like the zero vector and the identity matrix and so forth and so on. Just make sure that all of those work. Debug the matrix by matrix multiplication and debug the TRS multiplication at 0 as well as like an actual TRS multiplication. So yeah, that's a pretty nice little test class. Over here we also have like a singular test for the vector 3D inner product, just to make sure that that was also calculating properly. So as far as like actual engine implementation and how it runs, there isn't too much to really point out. I think I fucked up a couple of things. For some reason I couldn't figure out why my rotation caused there to be a growing and shrinking in the radial distances which it would rotate around the expected center point. So I'm not sure what's going on there. I know that I then re-implemented it in C++ and had absolutely no fucking issues whatsoever. So I'm not sure. It's probably the setting of a vector somewhere that I'm just not seeing. But we'll start with this. So this is me defining the camera controller, the one using a perspective matrix. Figured I'd put it in here because I went all the way of work of writing it. I don't know where this error is coming from. For some reason it says that the matrix isn't valid. Who knows? But it does work, I'm pretty sure, or it did. Position, let's see if that's working. No, I guess it's not working. Oh well. We do have this object scene, and you can see the camera controller script down here, and its zoom and position and rotation components. And so basically over here are a whole different bunch of objects that I've defined. I did kind of mess up with the vector arrow because after rewatching the lecture, I don't think it was what was being asked for, but we'll get to that in a minute. Basically, if we run this now, we can see that the camera matrix is definitely applied because it starts at a zoom of 0, and when I zoom in, there's the object, right? We can see that the camera moves as expected as well, so that's 10 out of 10. We can also see that the rotation of the camera is fine. Not getting that weird warping here either, which is kind of interesting. If we actually click on that square, I can show you the way that the components are kind of set out. So you have a translation, a scale, and an orientation, and a list, which just contains this point class, right? So you've got a reference to the object that is the point. You've got a reference to its initial position and what the transformed position is, just to read and visualize the changing of those vector coordinates. Um, so now if I move it, you can see that it translates correctly on the x scale and the y scale. That's not an issue. You can see that it also scales fine, both separately and on a singular axis. And as I said, you can see that weird rotation effect taking place there that I couldn't quite figure out, which is interesting, and I'm going to have to spend some time debugging that to figure out where I went wrong. So that's the requested square object. We can also see the point, and to be honest, wasn't sure how to employ scale on the point, so I kind of just did unless you want me to like actually grow the size of the sprite, in which case like I could have done that. It's very hard to visualize rotation on this. I should have probably put like a debug function in, but you can see the translation is working just fine. So that's the point, and then got our isosceles triangle. As you can see, that translates, and it does it on both axes. There's scaling, which is fine, and then rotation, which still has that weird growing and shrinking bug that's going on. Not sure, as I said, where that comes from. The right angle triangle, yet again, this will do exactly the same thing if I play with it. So you can kind of see that there. And then there's also the vector arrow, and you'll see where I went wrong with the vector arrow. It's just a big arrow. I definitely misinterpreted the assignment outline there. Definitely scales perfectly fine though. And the orientation, yet again, has that weird warping effect, which is interesting because one thing that I did do, and I haven't shown prior, is that I actually have capped the rotation as well. So if you, where are we? Be in the rotation component. So yeah, I've got this handy little function that just caps the rotation between 0 to 360 degrees effectively. So that should be handling that growing and shrinking issue, but it's not. So as I said, no idea. But that's my implementation for this project, and I've had a lot of fun learning about matrices and affine transformations. From this point, I would quite like to take them into probably C++ with a simple graphics library and play around with the implementation of sprites and using things like a shearing matrix or a reflection matrix on top of the TRS components and general affine transformations. I feel like that would be a really interesting thing to spend a bit of extra time on. I am very happy with my ability to actually employ the core mathematics that's required, because I know that the core mathematics itself is fully functional. It's been really enjoyable knowing that I am capable of implementing that level of programmatic mathematics, which is fantastic. I also think that this has some really interesting applications in terms of what you can do with objects that follow a radial pattern around a center object. And that's another thing that I think I will endeavor to explore further post the completion of this assignment. Anyway, that's everything. Thanks for hearing me and listening to me ramble on about this code base and project. Have a lovely day.